Let's start by taking a look at what the pattern has been leading up until this day. For the past week or so, we've had this strong ridge of high pressure over North America that was set up in a way that wasn't really allowing cold air to funnel down from the Arctic. You can see let me go over to the 850, so just above the surface, shows temperature anomalies just off the surface. So you can see most of Canada has effectively been extremely high anomaly as far as their comparison to average temperatures, and the same was at the surface. I mean, they're talking 20 to 30 degrees, in some cases 40 degrees above normal. So this, as our typical source region in the mid-Atlantic for cold air, it wasn't there to be tapped. Everything was bottled up in the Arctic. You see this below normal anomaly down south. That's mainly a product of the subtropical jet stream bringing pieces of energy across. Not really, you don't want the cold air to come from the south, you want it to come from the north. So there's a reason up until, here we are, the 29th, you can put this into motion, you can see Canada's still warm all the way through yesterday, New Year's Eve. But look at the transformation. I'll show the temperature anomaly first. You can see the pattern shift, and then we'll look at why that's happening and what that means for us in the Mid-Atlantic. So look at Canada. This is as of this morning, effectively. And if we put this through as we get to Wednesday, Thursday, Friday, you can start to see some cold air start to come through, some pieces of energy come off the Pacific Ocean. And then if we keep going, you can see this ridge building in Alaska. You can tell it's a ridge when you have warm anomalies over Alaska into the Arctic region. And then down, it funnels the cold air off that ridge down through Canada. And then as we get into the middle of January, you can see what was once, we go back to the beginning of this run, extremely high temperature anomalies, and now we're the complete opposite as we approach the middle of the month. So as we tap into this cooler air, which might take a little while, it's expected to dump into the west first, but that will set the stage. One piece of the puzzle is cold air, cold enough air to provide chances for wintry precipitation. There's other pieces too, so let's take a look at that. So let's go up to the upper levels. When I look at the weather maps, I always start in the upper levels at what's called 500 millibars. And this is a good, I could be wrong, but 30,000 feet off the ground, basically where planes fly. And what this is kind of the steering currents for storms at the surface and for high pressures. And you can kind of, when you look at this enough, you can gauge what kind of setup you're dealing with. And here we are. Let's go back to today. And you can see the ridge building over Alaska. You can see some northerly flow working its way into Canada, which is a big change from what they've seen for the past several weeks. And pieces of energy coming off the Pacific Ocean along the subtropical and phasing with the subtropical jet stream here. Put this into motion, and the pieces that we're looking for then is for the storm system that's going to impact us on the 7th and 8th this coming weekend. We want to see what pieces of the puzzle are lining up to give us the best chances possible. So what we typically want to see, is a ridge in the west and a trough in the east. It's not really the case this time around, though. So we have this first piece of energy here, and if I bring you to the surface, you'll see there's a low pressure in the Gulf that's going to basically just slide off the coast. Might bring some light showers, rain or snow showers Thursday, but really it should be a dry frontal passage, and behind that is this area of high pressure, which is a good thing. High pressure will rotate clockwise, will bring down some cooler air. You can see that low pressure finally starts to form well offshore, but this could play a pivotal role in the next system. So let's go back to the upper levels, and you'll see the next trough the next short wave, the little piece of energy here that's coming off the Pacific. And this is common for an El Nino setup, to see these pieces of energy ride along the southern tier. Meanwhile, a ridge of high pressure is sort of present out west, but this is drawing just enough cold air to bring down this northern stream energy that will bring colder air to our area. But this is our piece. This is our next system. So we see this thing coming across the southern tier. We get it to Texas. And what I'm looking for now is, all right, well, how do we avoid this thing, which is pretty strong here? Looking at the axis of the trough, it's almost neutral by the time it gets to Louisiana. And typically, if you're west of the Mississippi River and you're at a neutral to negative tilt, odds are this thing is going to cut to your west, unless you have what's called confluence. You see this energy here coming up and over the ridge. You have the polar vortex here, and these yellow highlighted areas are what's called vorticity. So these pieces of energy are following the upper level pattern, and this basically creates what's called confluence. You have the energy coming up from the southwest, energy coming down from the northwest, and right here I would expect a high pressure to form to the west of where these areas meet. Let's go to the surface map again, and you can see high pressure right there. So the question is, will this high pressure, as the low pressure is forming in the Gulf and the high pressure up north, you really want this to be, let me zoom in a little bit. So this high pressure is in position A. So for cold air to be funneled at the surface to our area, you want a high pressure basically to the north of New York, generally speaking, to Quebec. Could be northwest of Maine. I mean, somewhere in this general region here. If it drifts too far to the east, the surface winds start to shift more easterly onshore, pulling in mild air from the ocean. If it's too far removed to the west, it's just not going to bring the cold air down from Canada here. And then furthermore, this needs to really stay in place or anchor in place. And in order for that to do so, you want the confluence to anchor in place. So let's go back to the upper level maps again. And I shifted the view to show you this. Again, southwesterly winds, west and northwesterly winds. This area is where the confluence is. And does this stay in place enough to keep this system from cutting to our west? Is because basically we have effectively a wall where once the system coming up from the south feels that, it's going to shift its energy offshore and transfer that low offshore. And that's also a product of the temperatures at that point. Let's take a look at surface maps, temperature-wise. So it's not an Arctic outbreak that's preceding this storm, but you have ample what's called antecedent cold, antecedent meaning prior to the storm system's arrival. And this is, of course, overnight, so it will be coldest. But even during the day, we're in the mid-30s here, mid to upper 30s in the Philadelphia area. And there's been plenty of winter storms in the past that have had antecedent conditions just like that. The question is, will it maintain as the storm comes up? So let's go back to the surface map. And you'll see the low pressure at this point getting stronger as it comes out of the Gulf. The moisture is being drawn up from the Gulf of Mexico. You can see the southerly flow coming around the low pressure, the weak high pressure that was following that initial system from the 4th of January is working in conjunction with the low and drawing up Gulf moisture. This is what's called precipitable water values. Anything that's in the yellow shading is just above normal, significantly above normal. And you bring this moist air over the cold air, and that's what creates the precipitation in part. So going back to look at the surface maps, where is that high pressure? Let me go to a different view here. So you have that high pressure in a pretty darn good spot. The clockwise flow is bringing the cold air down to the surface. You have the low pressure coming up, and you can kind of see here, see how this is what's called there's a primary low that is going to track to the west. But once it feels the cold air at the surface, it's going to want to transform and find the path of least resistance, which will be right along the coast. So the cold air over the land and a mild air over the water, and it's going to create what's called a baroclinic zone, and that is where the storm system will typically follow. But then once it hits that wall of confluence in southeastern Canada, wrong one, which is basically this right here, it just can't progress any farther north. So that also will help it transfer to the coast. So the question is, will this confluence stay in place, or will it shift north or south? If it shifts too far to the north, this system will have an ability to cut more to the west and proceed more to the west of Philadelphia before it transfers energy to the coast. And by then, southerly flow will have eroded any of the cold air, and we'll be dealing with mainly a rainstorm in the area. If this confluence shifts to the south, that will help the cold air stay in place longer and might help the storm shift farther to the east and keep the area colder for more wintry precipitation. So that's one piece of the puzzle. So let's take a look at the trend. Another good thing to do when you're looking at weather maps is see, all right, well, this is a snapshot of time at around midnight on Saturday night, but what has it done over the past few days? Let's take a look at that. So if we put this into motion, we could say trend over the past 3 days. So if it runs 4 times a day, the past 12 runs would be 3 days of runs. So and it'll pop up a map and see the trend. So I'm looking for, all right, well, is this is this confluent area stable? Is it shifting north or south? And it's generally pretty stable. You can see this is the January 4th storm that is not phasing with that energy, which at first we thought would be a challenge, but actually it's not. There's so much vorticity coming down around the polar vortex that this confluent area is fairly stable. It's bouncing around 50 to 100 miles or so each run. But this is something we need to watch. If this does shift north, harder for us to stay snow. If it shifts farther south, definitely better cold air, but it might shift it too far to the south where it misses us. So it's a very delicate balance, probably like a 100-mile window for this confluence to stay within for us to get snowfall in our area. Now let's run the same trend map over the past 3 days just for the continental United States here and look at the main features. You have that confluence up here that we looked at from a different angle. You have the low pressure trough that's coming across Texas in that vicinity. And you also have another interesting element that has popped up over the past couple of days, which is more energy coming in off the Pacific Northwest, off the Pacific Ocean. So let's run a trend map for this and just see if anything jumps out. Again, we're looking for the different components that could impact the storm track, how much cold air can remain in place. And you can see here, not too much jumping out here, and I know the view here is a little challenging to see, but let me see if I can. All right, so taking a wider view here. So the main thing is we look at the confluence again. It's a little bit easier to see here with the blue versus the white. So if this blue is moving too far north, too much, this system can come farther to the west before it transfers energy to the coast. That'd be a warmer solution. If this blue over the next few days comes down farther south, the opposite would be true. So trying to find that balance between the two to bring us cold enough conditions in the storm just off the coast so it doesn't bring in too much warm air. The trough itself, I mean, it's bouncing around a little bit, but same general vicinity, same general tilt to the axis. You don't want this thing to take a negative tilt. Will be the base of the trough will be on a northwest to southeast axis or angle. Right now it's north-northeast to south-southwest. That's called a positive tilt. As long as it goes neutral right around the Mississippi River, that's a good sign. That's what a lot of our big storms have done. And then this energy coming in off the Pacific coast, kind of tough to tell from this map, but there is a quicker trend to the energy coming in. We're not quite sure what impact that might have on the storm system quite yet, but this is a big variable that we're going to keep an eye on because there could be what's called kicker energy that if it comes in and is oriented in a certain way, it could actually shove this system far or faster out to sea and be more of a southern slider. Or it could actually help us from cutting. If energy comes in from the northwest, it could actually be another force that keeps the surface low farther to the east. So that's a big variable, but overall, it's a good setup where we could sneak in a potential winter storm. Now let's look at another map here to show the variability in the depiction of snow versus rain. This is the GFS ensembles, and it shows 20 different members of the ensembles are multiple members that just have different starting assumptions, and they run this simultaneously to see if there's consensus. So if a lot of these different ensemble members show a similar solution, that gives us confidence that's going to be the outcome to expect. Now, when we're 4 to 5 days out from the system arriving, it's going to have variability. And this one has typical variability where you have some that are, look at this one down here, staying well to the south. And that would bring absolutely no precipitation at all to Philadelphia. You have others that are good old-fashioned snowstorms, some stronger than others. The pink is the heavy snow. And you have others that are kind of a mix. You might have a start of snow and change to rain. You might have some that are all rain from beginning to end. So that's typical variability. We just keep an eye on this for the level of consensus between the ensemble members, and there's multiple different types of ensembles that we look at to get a feel for if the different models all agree with each other, not only the individual members of each ensemble, but the different models, the European, the Canadian, the American, the GFS here, the GEFS. If they all are in consensus with each other, that's a great sign. Right now, they're not. There's some similarity, a lot of overlap, and really the favored areas, if we pull up another map here, are the far interior. So you have I-95 right now is looking as the battle zone between rain and snow. I would not be surprised if there's a growing area of mix that shows up on the computer models over southeastern PA if the system continues on the similar track. There's a lot of warm air that's going to be coming up over the surface. So the surface could be below freezing, but you're going to have a warm layer somewhere in the atmosphere that could change things to sleet, maybe freezing rain. So that'll be fine-tuned as we get closer to the system. But overall, this is showing the percentage likelihood of over 6 inches of snow. And you can see 50+% from far northwestern suburbs of Philly into central PA, the Appalachian Mountains, up to the Poconos and farther northeast from there. So that's for having over 700 days in Philadelphia with not even an inch of snow, this would be a big change from the norm for what we've experienced. So this would be a great potential for the ski resorts to get some snow base, which they haven't had all year, outside of one system that quickly melted away. But also the other map is showing the European ensemble mean snowfall expectation. Now this will bounce around usually pretty substantially over the course of each run. This thing runs every 12 hours. The most recent one today on New Year's Day shows, again, about a 6-inch mean through the northwestern suburbs up into the same areas we just covered before. So when I see this, I see a pretty sharp cutoff between rain and snow, or rain and wintry precipitation, which is commonly along the fall line here, which is where the elevation starts to increase just northwest of the city of Philadelphia, basically all of 95. So 95 is built in a pretty flat area. Just above that, it's no surprise to me that you're going to have a much higher chance for snow. And to get out of the mixed zone, your best chance is, I would say, the counties above the northwestern counties from Philadelphia. So Lehigh Valley, Lancaster, Harrisburg. But this is not a forecast. This is just an indication of what a reliable ensemble mean is showing, and it's a good sign. Typically, for us to get confident around snowfall, we want to see a mean of 3 inches or higher. And you want to see this over the course of the next few days, of course, because we're still several days out. But this is a very strong signal that we have not seen in quite some time. But the caveat is this absolutely can and will change in some form or fashion. A potentially exciting time in the weather world. Stay tuned. Lots will change. Right now, I'm saying it's about a 35 to 55% chance that areas from Philadelphia north and west will see a plowable event. The highest odds are certainly north and west of the city, and even north and west of the first set of counties northwest of the city. So Lehigh Valley, Lancaster, Harrisburg, certainly the Poconos, and anywhere along the Appalachians really have the highest confidence, but even those areas could see nothing or could see rain. So you just don't know yet. But the signal, the setup of the upper level pattern is favorable for a wintry event somewhere in the mid-Atlantic this coming weekend. I will keep you updated. I'm excited. Hopefully you are too. And snow lovers, think snow.